So in the last video, we practiced finding GCFs of terms, and now let's use that practice that we had for finding greatest common factors and do some actual factoring problems. So you're going to notice that our next examples, we have some polynomials. What we're going to do is factor out the GCF, or the greatest common factor, out of each polynomial. So in number 1, we have 40x squared plus 15x. And we're going to look at those two terms, compute the GCF. And a 40 and a 15, as you know, only have a 5 factor in common. So that will be part of our GCF. And then we've got x squared and x. And so they both have an x in common. So our GCF will be 5x. So we're going to rewrite the problem as the product of two factors. And that's kind of like reverse distributive property. So write the 5x and put the parentheses, and then you're dividing. You're looking at this and say, okay, 5 times what is 40? Oh, it's 8. And then x times what is x squared? Oh, it's another x. So 8x. And then 5 times what is 15? That's 3. And we already have the x. 5x times 8x plus 3 is our factored form. And I always think, let's look at the answer, the binomial, and make sure we didn't miss any common factors, and 8 and 3 do not have anything in common. And then the easiest way to check these problems is to go ahead and distribute, and at least you should do that in your head really quick and just say, okay, does that make sense? Do I get a 40x squared when I multiply 5x times 8x? Yes, I do. Do I get 15x when I multiply 5x plus 3? Oh, I do. Okay, so this is my final answer. Okay, let's go to the next one. In this problem, we have 48y to the 10th minus 30y to the 4th. We're factoring out greatest common factor. 48 and a 30 have a 6 in common. And again, if you don't see that right off the bat, then our last video gives you some techniques for being able to find a GCF. So take a look at that last video. And then between y to the 10th and y to the 4th, the y to the 4th is in common. And now 6 goes into 48 8 times. We factored out 4 of the y's from these 10 y's. So how many y's are left? Yep, y to the 6th. And then 6 goes into negative 30, negative 5 times, and we took all 4 y's out. So this is our final answer. And notice that when we check, I'm just going to remind you that when you multiply powers of y, that's a product rule, and you add the exponents to get the y to the 10th, right? So that's kind of checking. Next problem. So now we have a trinomial, 3 terms, degree 14, that's a review, right? And the coefficients are 56, 49, and 28. Can you tell what the GCF is between those 3? You might recognize them as all being part of the 7s table, right? So they have a 7 in common. So our GCF will be 7, and then we have our smallest power of x is x to the 5th. So 7x to the 5th is our GCF. 7 goes into 56 8 times. Now we pulled out 5 of the x's from the 14 x's that were originally there. So we have 9 x's remaining. 7 into 49 goes 7. We pulled out 5 of the x's from the original 9. So we have 4 x's remaining. 7 into negative 28 is a negative 4, and we pulled out all 5 of these x's. So that's our final answer. Now this next trinomial has 2 variables. By the way, just so you know, the degree of this trinomial here would be 10. And that is because we do add the 7 and the 3 here when we're talking about degrees, when our terms have more than one variable, just so you know. GCF between 36, 24, and 12. If you notice that all 3 of those are in the 12s table, you're absolutely right. The 12 divides into 36 and into 24. So 12 is part of our GCF. But again, if that's something that you don't see right off the bat, please go back to our last video where I showed you a technique that you could use to find these. Okay, so 12. Then all 3 terms have one x in common, don't they? So we're going to use x as part of the GCF. And all 3 terms have one y in common, so we're going to use y as part of the GCF. There's our parentheses. And then we divide 12 into 36, which is 3. We factored out 1x out of the 7 that were there. So we have 6 x's remaining. We factored out 1y out of the 3 y's that were originally in the first term, so we have 2 y's remaining. For our second term, 12 divides into 24 twice, times 2. We've pulled out the x, so no x's are remaining. And we've pulled out 1y out of 2, so we have 1y remaining. For our third term, 12 divides into negative 12 minus 1. And then we've pulled out both the x and the y, so minus 1. By the way, this third term is sometimes missed by students. So just a note for you that if your GCF that you're factoring matches one of the terms, then in your factor that's in the parentheses, there will be a 1, right? Because you're dividing. It's like you're dividing to get this 1 right here. Sometimes my students miss that last term because they think, oh, I've taken out the 12xy, so there's nothing left. But actually it's 12xy times, and in this case it's a negative 1 because we have the sign. So this is our answer here. In this next example, we have once again a trinomial. Can you figure out what the degree is? Okay, you're probably going to say it's 9 because you're looking at that first term, but actually the middle term has degree 12 because we have the 4 and the 8, and that's the largest of the 3. So the degree of this trinomial is 12. Just a little FYI for you. But notice that our first term is negative. What we're going to do here is when we factor out the greatest common factor, we're going to go ahead and make it a negative factor that we factor out so that that first term in the parentheses stays positive. That's just a technique we're going to use in future work. So we want to practice it here. And 21, 14, and 21 have 7 in common as the greatest common factor. You probably knew that. So we're going to take out a negative 7. And then with those r's, we're going to use the r to the third from the third term. And with those t's, we're going to use t to the fourth. Open a parentheses now. Okay, so we're dividing here. So negative 7 divided into negative 21 is a positive 3. We factored out 3 of the r's out of the 5 that we started out with, so there are 2 r's remaining. And we took all the t's out. So that's our first term. With our second term, we're going to divide negative 7 into negative 14. That's a positive 2. We took out 3 out of the 4 r's, so there's 1 r left. And we factored out 4 out of the 8 t's, so there are 4 t's left. In the third term, 21 divided by a negative 7 is a negative 3. We took out all 3 r's, and we took out 4 of the t's, so remaining 2 t's. So that's our answer. Do you see? Are you starting to get an idea of how to handle especially those variables? Okay, number 6. Matter of fact, if you want to pause the video right now and just try number 6 on your own, why don't we do that? So pause the video. There's your problem. Go ahead and pause that video now. Try it. And then when you unpause, I'm going to give you the answer. Okay, here's my answer. The greatest common factor of the 3 coefficients was a negative 8. We pulled out a negative to make that first sign inside the parentheses end up positive. We took out 2 a's and 1 b, and then that gave us 6b minus 7a plus 8a cubed b cubed inside of the parentheses. How did you do? Awesome. Okay, I want to show you these next two because they're kind of tricky, but we're going to be using them in the next video. So notice that this time I've got my plus sign here, and what I'm going to do is I'm going to look at this product here as one term and then this as a second term. They've got the plus in between. Okay, so we have terms in which we have parentheses within the terms. Do you see that? It's a little bit different, isn't it? But can you see that those two terms that are highlighted in green, what do they have in common? If you said the x plus 7, you're absolutely right. So the GCF this time around is this binomial. So we're going to go ahead and pull out x plus 7. Okay, see how they have those two in common. We're going to use that as the GCF, and then we're going to open a parentheses. And from our first term, since we took out the x plus 7, then we have the x remaining. So the x goes here. And then the plus. From our second term, we took out the x plus 7, so we have the 10 remaining. So we put the 10 there. So our answer is this product of binomials, x plus 7 times x plus 10. Do you notice what we did there? So the GCF happened to be a binomial, so we factored it out first. Okay, in number 8, we have the similar situation, don't we? We have these two 9y's plus 1 that are in common. And then just a note for you, what's hiding here in front of this parentheses? If you said a 1, you're absolutely right. I'm going to write it in because it's going to help us. So the GCF is the 9y plus 1. So we're going to pull that out and then open a parentheses. And that's going to leave us the 4y from the first term because we took out its 9y plus 1. And then minus 1 from the second term as the answer. Okay, I hope that makes sense because we're going to use this technique that you just saw in problem 7 and 8 when we do our factoring by grouping, and that's the next video. So go ahead and watch that next.